Okay, so this section is going to be on polynomials and factoring. It starts on page 27, and you should have your book open as we go along through this. I'm just going to briefly talk about the first couple pages of this section. Starting on page 27, it talks about what is a polynomial and, the definition of a polynomial. At the bottom of page 27 is important for you to realize that a polynomial and how to write it in standard form. Above example number 1, it talks about what that means. In standard form, a polynomial is written with descending powers of x. And example 1 talks about how to transform from something that might not be in standard form to something that is. So I'll write standard form. You should always write any solution in standard form. Okay. Next page, page 28, talks about operations with polynomials. And I'm just very briefly going to talk about this because what they're talking about now would be adding, subtracting, and multiplying polynomials. So sums and differences of polynomials all we're talking about there is combining like terms. Okay, so that's all on page 28. The other thing page 28 talks about is multiplying polynomials. And for that, you will either be using distributive property or FOIL. Okay, so I am not going to talk about combining like terms, distributive property, or FOIL. I may link some resources on the website for you if you need help with those, but I'm sort of hoping that we don't necessarily need help. I'm hoping that most of the things that we need today have to do with our factoring. So let's get into talking about factoring. And factoring, you have, 5 different methods that you should know how to use. Greatest common factor, difference of squares, trinomials, sum and difference of cubes, and grouping. Okay, important thing to remember is that you could use any of these together. So just because you use greatest common factor doesn't mean that you might not use another one of these. So at this point, I'm just going to go through some examples of some of these. I won't be doing examples of all. I want to point out that I will be putting this sheet, methods of factoring, and linking it on our website. It has some more specific examples, and of course we will be working on these in class. So I'm just going to do some short examples for you. So greatest common factor, sometimes abbreviated GCF. You're going to look for what all of your terms have in common. So if I wanted to factor 6x cubed minus 4x, I want to look, I've got 6 and 4. Those are both divisible by 2, and that happens to be the greatest number that they're both divisible by. So 2, and then if I look, they both also share an x. Factor out an x. Then what goes in the parentheses is what is left over. So 2x times whatever I write here should get me back to 6x cubed. So that would be 3x squared minus. And what would get me from 2x to 4x? Well, I'd have to multiply by 2. Now, some of the problems we'll be working on in class are a little bit more complicated than that. So let's look at x minus 2 times 2x plus x minus 2 times 3. And the temptation here might be to use distributive property to go ahead and, multiply these out. However, if I'm looking, I'm noticing that this distributive property would have an x minus 2, and so would this distributive property. So they actually have an x minus 2 in common. So I could factor out an x minus 2 from each of these parts of my expression. Then if I look, my next parentheses is what they would have left. Well, here's 2x plus 3. So be careful. Using distributive property is not always the most efficient way to factor or simplify. That would be greatest common factor. Next thing we want to talk about would be difference of squares. And you should be thinking about, as we go along, all of these methods. Some are more restricted than others, and difference of squares is a pretty restricted one. First of all, you have the word difference, so we're looking for subtraction, and then you've got squares, perfect squares. So 3 minus 12x squared. Well, I've got the difference piece, but I'm not quite sure about the 3 and the 12. I know those aren't perfect squares. However, 3 and 12 are both divisible by 3. So if I use greatest common factor to start, 3 times 1 minus 4x squared, well, 1's a perfect square, 4 is a perfect square, and so is x squared. So now I can go ahead and use difference of perfect squares. What goes, which is 2 binomials, what goes in the first part is whatever I have to multiply by to get my first term. Remember, they have to be the same. One is always a plus, one is always a minus. What goes second is what I have to multiply to get this term, and they also have to be the same. So 2 times 2 will get me that 4x times x. And that would be factored. Second example for difference of perfect squares. At this time, I might suggest that you pause the video and try this example before I go through it. So, 16 is a perfect square, x to the 4th is a perfect square, and so is 81. So I know I'm going to have 2 binomials, one's a plus, one's a minus. My first term is whatever I have to multiply by to get that first term, so that is 4x squared and 4x squared. The second term is what I have to multiply to get 81. That would be 9 and 9. Now, the temptation here might be to stop, but if I look at this second term, I've got subtraction, difference. 4 is a perfect square, x squared is a perfect square, and so is 9. So I can actually keep going. Now this term, or excuse me, binomial, I cannot, because I have an addition sign. So 1's a plus, 1's a minus. What times what gets me 4x squared? Well, that's got to be 2x and 2x. And to get 9, we'd have 3 and 3. Okay, so that would be difference of perfect squares. Next one I'm going to talk about will be trinomials. I believe on the sheet I'm going to post on the website, this is unfoil. Okay. So, for example, a very basic problem, x squared minus 7x plus 12. So, I'm looking for factors of 12 that sum to get negative 7. So I start going through my factors of 12. 1 and 12 would never get me to negative 7. 3 and 4, however, would get me to negative 7 if they were both negative. So I think I should have x minus 3 and x minus 4. So for the most part, people are pretty good at trinomials. Remember, you can always, if this is unfoiling, you can always foil your answer to see if you're correct. So last one I want to briefly talk about is grouping. Grouping you only want to use when you have 3 or more terms. So if you ever see 4 terms, you automatically want to think grouping. Possibly greatest common factor to start, but for sure grouping. Okay, so what I want to do here is I want to group the first 2 terms together and the second 2 terms together. Okay. Then I want to find the greatest common factor of each of my sets of parentheses. So greatest common factor here, x squared. And then I would have an x minus 2 left over. This minus sign can go out front. So what do these 2 terms have in common? I probably shouldn't have written that there. Sorry, guys. I need a little bit more space. They have a 3 in common. So left over, I would have an x. And this would need to be a minus in order to get back to this positive 6 that I started with. So minus 2. These 2 things inside the parentheses should end up being the same. So my final answer by grouping, x squared minus 3 and x minus 2. So I've done a few examples with grouping. Remember, we'll be practicing this in class. I will link my example sheet, and there are tons of resources that I have available if you don't remember all of your methods of factoring. But it is important for you to start remembering these 5 and when to use which one.